The Permian extinction, also known as the Great Dying, is a series of pulses that contributed to the most significant mass extinction in Earth's history. The Permian extinction is commonly referred to as the Permian Triassic, as it formed a boundary between the Permian and Triassic periods, alongside a boundary between the Paleozoic and Mesozoic eras in the geological timescale. Paleontologists and geologists argue that the extinction occurred during the latter 15 million years of the Permian period, roughly 299 million to 252 million years ago. Yet, many scientists claim that the extinction process was much more rapid, lasting roughly 200,000 years rather than 15 million. Nevertheless, it is the most severe event out of the major 5 extinctions, spanning the geological timescale. The Permian extinction is significant as 96% of all marine species were lost. Alongside, 70% of terrestrial vertebrate species had gone extinct. The event also marks the only known mass extinction of insects. Due to the immense species disappearance that occurred during the Permian extinction, the recovery of biodiverse land-dwelling life took immensely longer, estimated to be 10 million years. Yet, the re-diversification of localized marine ecosystems took roughly only 2 million years to recover, therefore alluding to the theory that the extinction was much less severe in some areas over others. However, the question that truly remains is what exactly caused the Permian extinction? What different factors came together to cause the most severe extinction in Earth's history? This question will be analyzed throughout the documentary as we take a closer look at the different elements that led to the event and the impact they left. Pinpointing the exact cause was found to be difficult as the event occurred over 250 million years ago. Much of the evidence has either been destroyed through time or buried deep within the many layers of rock on Earth. Since the seafloor completely recycles every 200 million years through the continuous process of plate tectonics and seafloor spreading, there is no useful evidence left under the ocean floor. However, while the exact causes behind the Permian extinction remain unknown due to the immense time gap, the geological community has come together to accept a few different theories of factors that led to the event. It is hypothesized that a mix of catastrophic events and gradual processes intertwined together, leading to the event. The catastrophic events include asteroid impacts, increased volcanic activity, and methane release from the ocean. The gradual processes include sea level change, increasing anoxia, and increasing aridity. The first hypothesized cause of the Permian extinction is known as the impact event. Scientists speculate that an asteroid collided with the Earth, leading to the Permian extinction. This led to the search of a large impact crater at an appropriate age for the time period. Reported findings showcase evidence for the impact event as a cause of the Permian extinction. This included rare shocked quartz, trapped extraterrestrial gases, and meteorite fragments located in Antarctica. Geologists speculated that an impact crater located on the sea floor would be proper evidence as a probable cause of the Permian extinction. However, such a crater would have disappeared as the ocean floor is 200 million years old and is continually changing through plate tectonics. The asteroid hypothesis is still probable, however, because 70% of the Earth's surface is covered by oceans. An asteroid would have been twice as likely to hit the water than land. Nevertheless, the impact event is a respected theory as a factor leading to the Permian extinction. The impact event may have also triggered other events leading into the extinction, such as volcanic eruptions. This would explain why the disappearance of species was so abrupt, rather than slowly dwindling over time. The Permian extinction concluded with volcanic eruptions covering stretches of land and ocean floor with basalt lava. The most significant volcanic eruption to spark the extinction was the eruption of the Siberian Traps. This is one of the largest known volcanic events on Earth that covered over 2 million square kilometers of the Earth's surface with lava. Although volcano eruptions may have not been the single factor leading to the Permian extinction, they played a significant role as they intertwined different elements on Earth together. The volcanic eruptions of the Siberian Traps are theorized to have pushed large dust clouds and aerosols into the atmosphere. This, in turn, blocked out the sunlight from hitting the Earth's surface, which disrupted photosynthesis as the process relied on sunlight. This series of events decreased the biodiversity on the Earth and caused food chains that relied on the process of photosynthesis to collapse. The eruption was also predicted to cause acid rain once the aerosol chemicals were washed out of the atmosphere, entering the ocean. This process killed planktonic organisms and other vertebrates found in the water. Alongside this, these volcanic eruptions emitted immense amounts of carbon dioxide, causing the Earth to gradually warm. Once all of the dust clouds and aerosols were washed out of the atmosphere and instead onto land and water, the levels of carbon dioxide remained high within the atmosphere. The eruptions of the Siberian Traps threw high levels of ash and debris into the atmosphere, increasing the short-term cooling effect prior to the global warming once the dust and aerosols settled. Overall, the volcanic eruption sparked a domino effect of events that led into one another, decimating various life on Earth. Scientists had noticed a swift decrease in the isotope ratio in carbonate rocks roughly 500,000 to 1 million years prior to the end of the Permian period. The alterations in the carbon cycle seem to coincide with the Permian extinction as a cause and effect relationship is present. The reason why an alteration in the carbon cycle is significant because it may indicate a disruption in the biological cycle. Scientists argue that the unusually immense levels of carbon trapped in Permian sediments may be due to high levels of ocean anoxia, which is low levels of oxygen within water. It is theorized that the volcanic eruption of the Siberian Traps may be the key element that led to the alterations of the carbon cycle. Plants were unable to filter high levels of carbon. Instead, these volcanic eruptions caused high levels of gases to enter into the atmosphere, while dust and ash blocked sunlight. Similarly, the eruptions of the Siberian Traps contained high levels of methane. These high levels of methane caused a significant increase in the global temperature, as methane is a powerful greenhouse. Evidence suggests that global temperature increased by roughly 6 degrees Celsius. Anoxia refers to levels of dissolved oxygen decreasing in areas of ocean, fresh, or underground water. A severe deficiency of oxygen in the ocean is one of the well-known factors that led to the Permian extinction. Scientists were able to find an array of evidence proving that the process of anoxia was present at the time. However, some of the evidence in sites such as China and Greenland prove that anoxia was present prior to the Permian extinction, as low levels of oxygen were already present. The Siberian Traps volcanic eruption caused for high methane and carbon dioxide levels to increase the temperature of the climate. In turn, the enhanced greenhouse gases and warming atmosphere caused for oxygen levels to decline. Additional chemicals from the acid rain runoff entered the water, polluting ecosystems through the water cycle. All of these factors intertwined as one, leading to the mass extinction of critical organisms. The significance of anoxia is the impact it has on aquatic life. Toxic oxygen-depleted water is terrible for marine life, as it causes widespread death. Marine organisms suffered the greatest loss during the Permian extinction, as 96% disappeared. During the Permian era, 286 out of 329 marine invertebrates went extinct. This, in turn, declined the biodiversity of aquatic organisms with a decrease in speciation. While some species were able to contend with the Permian extinction, a few ocean organisms, such as the eurypterids, trilobites, and acanthodians, went completely extinct. The decreased oxygen levels in the ocean primarily affected organisms with calcium carbonate skeletons, such as coral. This is because these species were dependent on stable carbon levels in the ocean to produce their skeletons. With the immense decrease in oxygen levels, these organisms were not able to form skeletons. Alongside this, ocean acidification caused by chemicals leaching into the water through volcanic eruptions aided the decline of marine life species. Species biodiversity quickly dwindled as only a few organisms were able to survive the low oxygen levels of the oceans. The immense rate at which these marine organisms disappeared was catastrophic. Ocean anoxia allowed for certain bacteria to thrive. This bacteria in the water released immense amounts of hydrogen sulfide emissions into the atmosphere, poisoning terrestrial plants and animals. This not only significantly weakened the ozone layer, leading to fatal levels of UV radiation, but also decreased biodiversity of terrestrial life on Earth. This theory is believed to explain the mass depletion of plants during the Permian extinction. While plants are relatively immune to mass extinction, many different varieties disappeared with the release of hydrogen sulfide. The Permian era had a wonderful diversity of insect species, including some of the largest insects ever to have existed. The Permian extinction is the only known mass extinction of insects, as 9 out of 10 species disappeared. Insect varieties began to decrease during the mid-Permian period due to high levels of pollutants in the atmosphere. During the mid-Permian era, the Earth's major continents were joined together as one, forming the supercontinent of Pangaea. Due to the close proximity of the continents, weather patterns produced monsoons as ocean currents and climate shifted. The biodiversity of these coastal areas near the interior began to disappear as the continents shifted towards one another. Marine life began to deplete and approach catastrophic levels. While these factors didn't have an impact in the Permian extinction, it is important to note that Pangaea was already assembled by the middle of the Permian era. Therefore, Pangaea only played a gradual role in decreasing biodiversity, not strong enough to fully reach the significance of the other big 5 major extinctions. A hypothesis was published in 2014 arguing that an array of microbes known as Methanosarcina led to the Permian extinction. The evidence argues that these microbes were able to gene transfer during the Permian era, effectively metabolizing acetate into methane. As previously stated, methane was one of the key elements that led to the pollution in the atmosphere and ocean. Similarly, the microbes' rapid reproduction caused them to consume immense amounts of organic carbon that had accumulated in the sediment. These microbes were able to produce a sharp increase in methane and carbon dioxide in the Earth's oceans and atmosphere. Eruptions of massive volcanoes added to this process by releasing immense amounts of nickel, which is a cofactor in allowing for microbes to produce methane. In conclusion, an array of different causes came together as one, leading to the Permian extinction.
While geologists and the scientific community are unable to finalize why the Permian extinction occurred exactly, they have agreed upon the impact these several factors had leading to the event. It is significant to note that these different causes were able to lead to the Permian extinction as they interconnected into one another. For example, Siberian Traps volcanic eruption, also known as the catalyst, triggered a release of carbon dioxide and methane into the atmosphere. These chemicals then settled through acid rain, polluting the surface of the Earth alongside oceans.